Now that we have positive and negative numbers, we can talk about absolute value. The absolute value is defined to be the distance on the number line from 0 to your number that you're looking at. So for example, here we show the absolute value of 4 is 4 because the distance from 0 to 4 on the number line is 4 units. Similarly, the absolute value of negative 4 is 4 because the distance from 0 to negative 4 is 4 units. Distance is always positive, and that's why the absolute value is always positive, or 0. If we want to write that a little more formally, if I have an integer x, the absolute value of x is going to be just x if x is greater than or equal to 0, and the absolute value of x is negative x if x is less than 0. So let's make sure we can evaluate some absolute values. Absolute value of 20 is going to be 20. Absolute value of negative 5 is positive 5. Absolute value of 0, well, the distance from 0 to 0 is 0. Here I have the negative absolute value of negative 3. That's going to be negative 3, which is just negative 3. And how about the absolute value of 2 plus negative 5? Well, first we should add on the inside. So 2 plus negative 5 is negative 3. And the absolute value of negative 3 is 3, since negative 3 is 3 units from 0 on the number line. Let's look at some properties of integer addition. These should feel really familiar to you because these are all the properties that we saw with whole number addition. So if I have integers now, a, b, and c, if I add two integers, I'm going to get a unique integer. That's the closure property. Addition is also commutative over the integers. So if I add a plus b, that's the same as adding b plus a. It doesn't matter what order we add in. It's associative. So if I take the sum a plus b and then add c, that's the same as taking a plus the sum b plus c. And there is an identity in the integers. 0 is the additive identity, so that if I add 0 to any integer, I get that integer back. So we have one new property, and that's called the additive inverse property of integers. So now for every integer, there exists a unique integer negative a, which we call the additive inverse of a, such that if I add a plus negative a, I get 0, the additive identity. And if I add in the other direction, negative a plus a, I also get 0. Okay, by definition, your additive inverse is the solution to this algebra equation, x plus a equals 0. So it's the value that I can plug in for x to make that equation true. For any integers a and b, the linear equation x plus a equals b is going to have a unique solution, and that unique solution is b plus negative a. Here are some more facts about the negatives. So if I take the negative of a, or the opposite of a, I just get a back. And the second property says if I have negative a plus negative b, that's the same as the negative of the quantity a plus b. So you can pull that negative outside of that sum. All right, let's make sure that we can find some additive inverses. So what do I need to add to negative 3 plus x to get 0? Well, I need to add 3 plus x. So because negative 3 plus x plus 3 plus x, if you distribute that negative, I get negative 3 plus negative x plus 3 plus x, and that's negative 3 plus 3 plus negative x plus x. I'm using commutativity to switch the order of my addition, and I can associate this way. That's 0 plus 0, which is 0. Okay, so the additive inverse here is 3 plus x. What about the additive inverse of a plus negative 4? Here, the additive inverse is going to be negative a plus 4. And I'll leave it to you to check that that's true. And finally, the additive inverse of negative 3 plus negative x is going to be 3 plus x. Again, you should double check that you agree that's true. And you're going to check by doing exactly what we did for part A.